Okay, so let's start. Today we'll solve two questions from real analysis. This is a question number 43 and question number 31 from Gate 2020. So let me first play the video for question number 43. Okay, so today we'll solve Gate 2020 question. This is a question from real analysis and question number 43. So it is saying that let p between 0 and 1 and x is all such continuous all such continuous functions such that integral of f to the mod f to the power p should be finite. And for f belongs to in this space, we define this. So basically this is type of norm, not exactly norm, mod f suffix p integral of mod x to the power p dx to whole to the power 1 by p. Because this is finite, it's we have for f belongs to s, so that's why we have defined like this. Then the four options are given. You have to check which one is correct so that it's defined a norm or satisfying triangle inequality or it will converge. So these are the four options we have to check. Okay, so this is the NPTEL reference for this question that you can also check. Okay, so let's start solving this one. So what is x? X is f r to r continuous and integral over r mod x to the power p dx. So this is finite. Then we have defined this f suffix p to be the integral of f mod of fx to the power p dx to the power 1 by p. Right, then we have to check that this is a norm or not, and the next inequality satisfies triangle inequality or not. So if you check b, then so first we will check b that it is true or not. So let's check first b. To check, oh, and one important we have p is between 0 to 1. So this is a one important fact where p lies, p in 0 to 1. Norm f plus g p less than fp plus gp. Right, so this we have to check where f and g are in x. So we'll show that this is not true. So this you can easily check for taking characteristic function, but note that here characteristic function is not in this class x. We have to take the continuous function. So we'll modify this characteristic function a little bit to make it continuous and do this. So what is the idea? Let me tell. So suppose this is 0 and this is 1. So what we will do, and this is 1. So take a function like this. So we are basically exactly not taking the characteristic function and we make it continuous. So characteristic function we will take then 0 to 1 only, but this is not continuous. So we will make this little bit modification to make it continuous. So this will take f, and otherwise it is 0. So it is only supported in 0, 1. and take another function. So later I will take. So what is this? So this is our f. So what is the definition of f? Let me write. So this you can write also. So f is basically how it is defined. So it is 0 for x belongs to minus infinity to 0, and it is this linear function, right? Suppose let's also take this point to be, suppose it's 1 by 3, and let's take this is 2 by 3 where it is 1 in between. So on 0 to 1 by 3 it's a linear function, and at the point 1 by 3 it's take 1, so the function will be 3x, and at 0 it's 0, so x belongs to, so this is from 0 to 1 by 3, and now it is 1 for x belongs to 1 by 3 to 2 by 3. Then again it is a linear function, so it is at 2 by 3 it's 1, and at 1 it's 0, so it will take something like 3x by 2 minus 1 for x belongs to 2 by 3 to 1, and again after that we have defined it to be 0. So let me not write, let me write it here, union 1 to infinity, and make it closed, because the end point it will agree the value, so it does not matter. So this is our definition of f. So we will show that this inequality does not hold. We will choose some particular f and g where it is not satisfied. So we have taken this to be f. So this is a continuous function. Not f is continuous. And how we will take g? So g will basically take again the similar function, but just will shift by some number, so that their support will be disjoint. So just shift it something like, suppose let's say x by x plus 5. We're shifting it right by 5. So how it will, so it is supported in 0, 1, so it will be supported, and g will be supported on 5 to 6. So let's say this is 5 and this is 6. So it will take the value 1 here. So this is g. So g is basically shift of f by 5. Then g is also continuous. Now we have to check that these belongs to this class x. So you have to check that this norm should be finite. Note that this is also note that support of f. So where f is non-zero, it is basically this closed 0, 1. So support of f is where the function is non-zero and closure. So support of f is 0, 1, and support of g is closed 5, 6. So support of f intersection g is empty. And so what will be integration of over r fx to the power p dx. So this will be finite because continuous function and inside compact interval it is bounded function by 1. So this will give some finite value. So let's say this is this A. Define this to be A. So then, so this will give some finite value, right? Then what will be integration of G? So this is just the translation of F, right, by 5. And if you, because Lebesgue-Méhari translation invariant, you can change the variable x goes to x minus 5, then you will get basically the integration of F. Because this is same, just make the change of variable x goes to x minus 5. So this is again the A. So we'll get both integral of F and G to be A. So F is, we have shown F is continuous and both integral are finite. So F and G belongs to X. Now we have to check this one. So what is F plus G now? So F plus G. Note that this is F plus G. What is F plus G? So it is 0. So it is Fx whenever x belongs to support of F, means 0 to 1. For x belongs to 0 to 1, it will take only value G. It is Gx when x belongs to support of G, because we have taken this to be a disjoint support, so that our calculation will be easier. So this is here, and otherwise 0. Right. So what will be this integral? Means what is this? F plus G to the power P. So this is by definition R F plus G x P dx 1 by P. So note that it is otherwise 0, so only integral survive when it is 0 to 1 and 5 to 6. And from 0 to 1, it will be Fx, because G is 0 here, plus 5 to 6, it will be Gx, because their F is 0. And what we have assumed that this integral, first integral, because this is F is only supported at 0, so basically this integral is 0, 1. So this is 1. Let me write it. This is same as integral 0 to 1 Fx to the power P dx, right? And this is again same as integration 5 to 6, because support of G is only 5 to 6. Right. So we'll get both to be this A plus and again this to be 1 by P. So it's 2A to the power 1 by P. So if integral F plus G, we have got 2A to the power 1 by P. And what is Fp plus Gp? So this is the integration R Fx to the P dx to the power 1 by P plus integral R Gx P dx to the power 1 by P. So the first one is A to the power P and second one is also A to the power P. So you have got this is 2A to the power P. But is this true? That is this satisfied? But note that, but note that for 0 less than P strictly less than 1, 2A to the power 1 by P is strictly less than 2a to the power 1 by p. As means taking the whole power of p, 2 to the power pa is less than 2a, right? So this is true because p is less than 1. So for p less than 1, this is true. So means what is 2a to the power 1 by p? So mod f to the power p plus mod gp is strictly less than mod f plus gp. So you have got this is true for all f. No, for this f we have got this one. So therefore this means, which is saying that this is not true for all f and g. So option B is false. So option B is false. Okay, so we have shown that this satisfies the reverse triangle inequality. Means mod f suffix p plus mod g suffix p is strictly less than mod of f plus g suffix p. So therefore option B is false. And what is option A? Option C is saying that this defines a norm. So option A also means option A is also not true. Not if this defines a norm on x, then this will satisfy triangle inequality. Must satisfy triangle inequality. But as this does not satisfy, so by option B, A is also not true. A is also not true because it does not satisfy triangle inequality. Option A and B is false. And what is option C? You have to check mod f plus g suffix p whole to the power p is less than equals to mod f suffix p to the power p plus mod g suffix p to the power p. So let's check option C. To check for fg next. So we'll satisfy this is true. So first we'll prove this is one result. If p is between 0 and 1 and if s and t are bigger than 0, then s plus t whole to the power p is less than s to the power p plus t to the power p. So we'll use this to prove this one. So first so this proof is easy. Proof just let me say if you like. So how to prove this one? So fix S positive, then you can, so f is a function from then close 0 infinity to r. So if it's a function of t, you are viewing this as a function of t. right? So that then f of 0 is 0. If you put 0, you will get 0. And for t is strictly bigger than 0, calculate f dash t. What is f dash t? If you calculate, you will get basically t to the power p minus 1 minus s plus t to the power p minus 1. And this can be easily shown that this is bigger than 0, as since s plus t is bigger than t, which is 0, and as p is between 0 and 1, p minus 1 is strictly less than 0. So we have shown f0 equals to 0 and f dash t is bigger than equals to 0, means f is monotonically increasing and f0 is 0. So therefore, so ft is bigger than 0 for all t bigger than 0, right? So which means s to the power p plus t to the power p is bigger than s plus t to the power p. So this is the proof. So using this, you can prove this one. So this is done. Now I have to prove this one. This should be less than mod f to the power p plus mod f so to the power p. So this is by definition integral over r mod f plus gx to the power p dx. So now this we have used this one, that mod of f plus gx is less than mod fx plus mod gx. Use this one, so then what you will get? Mod fx plus mod gx p dx. And by the above result, so this is s, this is t, so s is mod fx, t is mod gx, so then this will be less than mod fx to the power p dx plus mod gx to the power p dx by above result. So then this is the mod f p plus mod g suffix p. So we have got f plus g p, no, this is to the power p. This is less than mod f p plus mod g p to the power p. So therefore this is true for all f g max. So if you take the pth power, then it is satisfied triangle inequality, it is saying, right? And what is the, so this is option C is correct. And what is option D? It is saying that if fn converges to f pointwise on R, then this in this fn mod suffix p converges to f mod suffix p. So to check if fn converges to f pointwise, then limit n tends to infinity, means this is converges here. We'll show again that this is also not true. We'll show this is not true. So we'll give a counter example. So take this fn, sequence of function e to the power minus x minus n square. So then each fn belongs to not continuous and they are integrable also, that you can check. Not fn belongs to x for all n. And so where this will pointwise converge. So whenever if you fix some x and if you take n tends to infinity, so note that e to the power, so n x minus n, it will goes to 0. So for each x, belongs to R, fn x converges to 0, right? So fn converges to 0 pointwise. Now you have to check that this converges in this is not norm, so there it will converges or not. So we have to calculate. So let's first calculate this one. What is this? So this is over R fn x to the power p dx. So what is fn? It is mod e to the power minus x minus n whole square p, and this is positive function, this is dx. Again n is here for fixed n, it is n is constant, right? So you can, and Lebesgue measure is translation invariant, you can make change of variable x goes to x plus n. So then it will be e to the power minus x square p dx, right? So what is this? So this is some, for particular n equals to 0, right? So this is f0. So what is this? Is f0 p, right? Because this, suppose this is defined for all n bigger than equals to 0. And so f0 is basically e to the power, where f0x is e to the power minus x square, right? And note that this is continuous and pth integrable function. So f0 is in x, and this is also positive, and this is strictly bigger than 0, right? Because this is positive function, as e to the power minus x square is strictly, so positive function if you integrate, and this is positive on a measured 0 side, so this is integral will be strictly bigger than 0. So this is, so what we have got, this norm is same as f0 p, and which is strictly bigger than 0 for all n. So can this converges to 0 function, because this is always bigger than, strictly bigger than 0 for all n. So therefore fn p does not converges to, so 0, it does not converges to 0 function, right? So it is converges pointwise but does not converges in this sense. So therefore option D is also false. So therefore which one is correct? We have got that option A is false, this does not define norm. Option B is also false, this does not satisfy triangle inequality. But it satisfies triangle inequality whenever there is a pth power. And the last one is also not true. So you have got option C is the correct. Okay. Okay, any question? Now then let's move to the next question. Okay, so today we'll solve Gate 2022 20 question from real analysis. This is a question number 31. So a function from R to R is given by this. This is a summation from n to 0 to infinity 1 by 2 to the power n characteristics of interval n to 1 n plus 1. And define for alpha belongs to R. Let's define this function S alpha is all such x such that fx is bigger than alpha, strictly bigger than. Then 4 options are given. You have to check which one is correct. Okay, so you have to check basically this set is open, closed or measurable. These are the 3 things you have to check for different values of alpha. Okay, so this is the NPTEL reference. This you can check. Okay, let's try to solve this one. So let's try to understand what this function is. So fx is given summation n equals to 0 to infinity 1 by 2 to the power n characteristics of n to n plus 1. What is this means characteristic function of means whenever x belongs to in this interval, this gives the 1. So basically characteristic of suppose any set x is it's 1 if x belongs to a and 0 if x does not belongs to a. So this is the definition of characteristic function. Now look how this function will look like. So let's say this is 0, this is 1, 2, 3, 4 and etc. So if suppose note that what happens when x equals to 0. So if x equals to 0 and if you put n equals to 0, so note so n equals to, so this interval is basically, note that this n equals to 0. So if you put n equals to 0, you will get open 0 to 1, this interval. And for n equals to 1, it will get 1 to 2. So it will shifting right. So at x equals to 0, this is open. So at x equals to 0, it's not there. Characteristic function will be takes the value 0 because x is 0 is not in the interval for n equals to 0 to infinity. So at the point x equals to 0, function will take the value 0, right? So here 0, and for any x negative, this is the same because this is from n equals to 0 to infinity, so intervals are shifting right. So this is the 0 function from minus infinity to 0. And what happens when if for n equals to 0, it will give the interval 1 and close to, open 1, close to, and there it will be value, it will give 1, right? So at this point it will take 1, but it is open. and from if you put n equals to 1, so it will give the interval 1 to 2 and it will take the value half. Right, next it will take 1 by 4 like this. And so on, right? Like this function. And so how this function will, this you can write. So fx, if you write it explicitly, so it will take the value 0 whenever x in minus infinity to 0, right? And 1 when x is in open 0 to closed 1. Next it will take half when x belongs to open 1 closed 2, and like that, right? And dot dot dot. So it will take 1 by 2 to the power n if x belongs to in this interval n comma n plus 1. So this is the function fx. Okay. Now let's check what we have to find. And S alpha is given. You have to find S half is open or not first. And what is S alpha? For alpha belongs to some real number, you define S alpha all such x in R such that fx is strictly bigger than alpha. Right? So first A we are doing. So S half we have to check. What is S half? So all such x in R such that fx is bigger than half. Okay, so you have to find all the points where f is bigger than half, strictly bigger than half. So note that which points is bigger than half. So these are the only when it is take the value 1, it's bigger than half, right? So it is in the interval open 0 closed 1. So this point open 0 closed 1. So this set will be, so all the points where it is bigger than half, it's open 0 closed 1. So is this set open? So this is not open, right? Because 1 is not an interior point. So S sub is not open. Right. So option A is false. Option B, you have to find S root 5 by 2 is not measurable. Same. S root 5 by 2. So this is all such x's again are such that fx is bigger than root 5 by 2. Not that root 5 by 2 it's bigger than, so root 4 by 2 it's 1. So it's strictly bigger than 1. So all such x where f is take the value is strictly bigger than 1. But there is no such point where f will take the value bigger than 1, right? So the set will be empty because all the values is less than 1. So this set will be empty, right? The function will not take the value, any points in which function take the value bigger than 1. So this set is empty. And we know empty set is measurable. So S root 5 by 2 is measurable. So it is saying that option saying that it is not measurable. So this is again false. Means this is not true. So we get this is measurable. And option C is saying that S0 is closed. Let's find what is S0. So S0 is all such x such that fx is bigger than 0. So you have to find all such x whose function is bigger than 0. Now note, for minus infinity to open 0, function will take the value 0, so this will not come. And for close 0, and for open 0 to infinity, function will always take the value bigger than 0, right? Because it is of the form 1 by 2 to the power n. So from open 0 to infinity, all such points will be there. So this set will be open 0 infinity. So S0 is closed, not closed. Because this is open interval. And option D, what it is saying? S1 by root 2 is measurable. S1 by root 2. So this is all such x such that fx is bigger than 1 by root 2. So which points will come? So bigger than 1 by root 2. Note that 1 is bigger than 1 by root 2. So all such points where if you take the value, this is inside this set. And is this true? That but half is not bigger than root 2, right? So this, because root 2 is less than 2, right? So these points, so only points where function will take the value 1 are only inside this set, right? So this you can take also. So this set is same as, because 1 by root 2 is somewhere here. So on the point where it will take the value 1 will be there. Same as fx equals to 1. So this set will be open 0, closed 1. So this is again measurable. Right, so this set is measurable. So what we have got? So yes, 1 by root 2 is measurable. So the which option is correct? Yes, 1 by 2 is open, so this is not correct. S half is not open, so this is false. S root 5 by 2 is saying not measurable, but we have got S root 5 by 2 is measurable. So option B is false. S0 is closed, saying, but we have got S0 is not closed. It's open interval. So this is, yeah, second false. And S1 by root 2 is measurable, that we have got. So option number D is correct. Okay. Okay, any question? Okay, fine. Okay. Huh? না 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 আমি করে দিয়েছি না আরও ছবি আপলোড করা যাবে আর কি করবি তো ঠিক আছে ঠিক আছে হুম হুম ঠিক আছে ঠিক আছে হ্যাঁ ঠিক আছে আমি করে দিয়েছি হুম ঠিক আছে Okay, then let's stop for today. We'll meet again in the next week. In the next week, we'll do two problem from functional analysis. Okay, thank you.